All right, so now we're going to talk about graphing linear and absolute value inequalities. So this, for the most part, if you know how to graph linear functions and absolute values, this is going to be pretty easy for you. So we have an example here that you can, if you want to, you can pause and see what they're doing. Otherwise, I'm going to just jump straight into exercise 1 and show you how to do this. All right, so the first thing we're going to do here is we're just going to graph this function, 3x plus 1. Now, we're going to graph this almost exactly like you did in algebra 1. All right, so this is how we're going to do this. Remember that this one right here represents your y-intercept. All right, so I'm going to put a point at 1 here. And then my slope is 3, which means I'm going to go from this point, I'm going to go up 3 over 1. Then down 3 over 1. So now the only thing you have to then look at, all right, if this is less than and not less than or equal to, I'm going to have to put this as a dash or dotted line through here. Okay, so I'm going to put a dotted line right through there. And that is going to be like that, unless if it's equal to, like this one, for example, when I graph this one, I guess I can go ahead and do that. 1, 2, 3, 4, 5. Then this y-intercept is 5, the slope is 1. So we have slope 1, 1 over 1, 1 over 1, up 1 over 1, up 1 over 1. All right, so this is going to be a solid line, and this is going to be a solid line because this is equal to. All right, so getting back to this one real quick, the only thing you're going to have to do with inequality is if it says y is less than, all right, there's actually 2 ways to do this. Y is less than, if you think about it, you're going to shade everything below the line. Now, below the line would actually be about everything below the line. Now, there's a few people that have a lot of trouble sometimes, especially if the slope is very, very steep, figuring out what is below the line, what's above the line. So another way to do this is you can pick a point. For example, if I didn't know which side to shade, right, I can pick that point 0, 0, which is technically my shaded side. So if I can test the point, and if I plug it into this equation, I would have 0 is less than 3 times 0 plus 1. So this is 0 is less than 1. Is that true? Is 0 less than 1? Then yes. Since that's true, that means I would have to shade on this side. Now, if I would have picked a point on the other side, if I would have picked a point over here, that would have given me some kind of false statement. For example, if I would have picked this point right here, which is negative 3, 0. So if I would have picked that point right there, let's see, y is 0, and then this would be 3 times a negative 3 plus 1. So that's going to give me 0 is less than negative 9 plus 1, which is going to give me 0 is less than negative 8. Is that true? Absolutely not. So therefore, that means that it's not going to be shaded right here. It's going to be shaded right here. Now, what that shade represents, the shading represents the number of solutions in this problem. So if you pick any point on this shaded area, that's going to make the true. It's going to make this inequality true, okay? But for now on, I'm going to just keep telling you that, for example, this is y is greater than. If y is greater than, I'm going to shade everything above the line. And if you don't understand why, or like you don't understand why I'm picking that side, remember, greater is above, less than is below. If you don't understand that, then just plug in a point either here or here and then figure out if it's true. If it's true, then the point that you picked, that's going to be the shaded part. Okay. Number 3, there's really nothing to it. You just have to solve for it. So if I subtract 4x from each side, I would have negative 4x minus 1. I'm going to go ahead and graph that. Negative 1 is right here. The slope is negative 4, which means I'm going to go down 4 to the right one. So 1, 2, 3, 4, and 1. And 1, 2, 3, 4 over 1. Okay. Now it's equal to, so I'm going to draw a solid line right through that. Okay. Now one more time. Now I'm looking at this one, not so much this one. Y is less than. Less than would be this point right here. Excuse me, this side right here. So I'm going to shade all of that. So that's essentially all I'm going to do with this. Let me do one more example like this one. Actually, I'm going to stop doing examples. It's the same thing. Solve for y. Solve for y. and then graph it. And remember, this is just greater than, so let me go ahead and graph it. The slope is -1, so I'm going to go down and to the right. Down and to the right, down and to the right. Slope of 1. I'm going to have a dashed line because this is just greater than, it's not equal to. So equal to, you draw a solid line. Dashed line means it's not equal to. And y is greater than. So y is greater than would be this other side of it. That's easy as that. Okay? So let's go on to the back here. Now we're done graphing linear inequalities. Now we're about to the absolute value inequalities. Now this turns out to be about the same thing. It's not that much different. All right, so again, pause here if you want to see what this example is all about. Otherwise, I'm going to jump straight into it. Now, obviously, I know how to graph absolute values. So if you need to grab a calculator to graph it, that's fine. But you should be able to do that too. Remember, of the absolute values, they're going to look like these, right? That means up 1, it's not being stretched. So I have the following points. It is equal to. Okay, so I'm going to have a solid line. Okay. Now it says y is greater than. If y is greater than the absolute value of x plus 1, all I have to do is shade above the line. And don't forget that the shaded area represents the number of the solutions that would make that true. So for example, if you pick any point in the shaded area, it's going to make that true. Okay. Now remember, one more time, if you have a little trouble, like you don't understand where to shade, you can always test the point. For example, if I test this point 0, 0, which I picked that one a lot because that was the easiest one, right? So test 0, 0. If it's a true statement, I would have to shade on this side. Absolute value of 0 plus 1, so it's going to give me 0 is greater than or equal to 1. Is 0 greater than or equal to 1? Nope. And if it's not, then that means that it's not being shaded here. And if it's not being shaded here, then it has to be the other side. All right, so you can also do it like that. All right, let's graph the next one here. I'm going to go to number 3. So let's see, y is greater than 2 absolute value of x plus 3. Okay, so on this one, I'm going to, remember all I have done here is I just added that to both sides, okay? I'm going to try to graph this one. Remember, I'm up 3, so 1, 2, 3 is being stretched by a factor of 2. And this one's just greater than, it's not equal to. So I'm going to have a dash line here, not a solid. Okay? So now, as always, I lost my pencil, there it is. As always, I just have to look at it. Y is greater than again. So if y is greater than, I'm going to shade above the line. Okay, and that's it for that. Let's just do one more here. Let's do number 6, and we'll call it a day. All right, so first I have to solve for y, right? So don't forget, I'm gonna have to solve for y first. Now this may seem kind of weird, but this absolute value of x plus 1, I can't separate that. So I'm gonna have to subtract all of this, all of the absolute value to one side. All right, so I'm gonna subtract all of that absolute value to the other side. So I'm going to end up with 2y is less than negative absolute value of x plus 1. All right, and then now I'm going to divide by 2 because I'm trying to get the y by itself. I'm trying to isolate it. So I'm going to end up with y is less than. Now, this right here, I can rewrite all of this divided by 2 as 1/2. Now, the negative just came from the fact that this whole thing is negative, right? So I'm going to have negative 1/2 x plus 1, absolute value of x plus 1. That and that means the same thing, right? Just an example that would be like if I have negative 5 over 2, that's the same thing as having negative 1/2 times 5. That's literally the change that I'm doing. I'm just giving you an example with numbers here that doesn't have any relevance to this problem. Okay, so now this right here, I'm going to have to graph it, right? So remember, I'm going to go left 1 here. Left 1, I'm being reflected. So that V is going to be pointing down now. And I'm being compressed by a factor of 1/2. Meaning it's going to be shrunken down, it's going to be compressed. It's actually going to make that V wider. So it's going to look something like this. Now let's see, this is going to be less than, so therefore I'm going to have a dotted line, not a solid line. Now in this one it says y is less than, all right? If y is less than, then I'm going to shade, excuse me, I did that wrong. If y is less than, then I'm going to shade everything below. Okay, so let's see. Let's just test a point, make sure I got it right. So we're going to test, again, I'm going to test the origin because that's the easiest thing to do. All right, I'm going to go back to the original equation, which is this one. So I got 0 plus 1, absolute value of that, plus 2 times 0. Is that less than 0? All right, that's going to give me 1, absolute value of 1. That's going to be 0. Is 1 less than 0? It's not. So therefore, that means that my shading cannot be on this side, so it has to be on this side. Okay?